Okay, next problem does not have to do with vectors. Due to repetitive storms, we're doing number 5. Due to repetitive storms in the summer, a tree grew so that it was leaning 12 degrees from the vertical, creating an obtuse angle. So I'm going to create this leaning tree. $12 degrees from the vertical. So we'll get some color in here, make it a green. So we have this obtuse angle now. So if it's 12 degrees from the vertical, that means the entire angle is 90 plus 12, which would give us 102 degrees altogether. That's going to create this triangle right here, which is an oblique triangle. At a point 20 feet from the tree, so here we have 20 feet from the tree, the angle of elevation to the top of the tree is 32.5 degrees. So if this angle is 32.5 degrees, and this obtuse angle is 102 degrees, that means that we have 180 minus 102 minus 32.5 degrees, leaving us with 45.5 degrees for this angle right here. Now that angle is important because we want to find the height of the tree. So we want to find the height of this tree. Well, the height is the perpendicular height, so we need to find this right here. Now, if this angle, I'll highlight it, if this angle right here is 120 degrees, that means that its supplement is 78 degrees. And in a right triangle, opposite hypotenuse, I could find the height of the tree by finding the sine of 78 degrees and setting that equal to opposite over hypotenuse. So the height over this value x. The height is thereby going to equal x times the sine of 78 degrees. Okay, so this right here is what I need to be able to calculate. Now that I know what I need to find, I'm going to go back to our first, let's highlight this in green. I'm going to go back to our first triangle, and I'm going to find that value x. X over the sine of 32.5 degrees is equal to this 20 feet over the sine of its opposite angle, which is 45.5 degrees. I'm going to cross multiply and divide, and I'll have 20 times the sine of 32.5 degrees divided by the sine of 45.5 degrees is equal to x. Once I find this value x, which is just some numerical value, I think that its value is something close to 15. I'll put it into my calculator here, 15.066 feet to be approximate. I'm going to take that value and I'm going to plug it in for x. So the height of the tree is equal to 15.066. I'm going to use the exact value in my calculator times the sine of 78 degrees, which will give me something less than 15. We'll put it into our calculator, and I get 14.737 feet. So the height of the tree is 14.737 feet. Now, once you can do this problem, number 5, you'll be able to do number 6, which is the next problem on the worksheet. Okay, so